Hi students, welcome to this session here at Infinity Learn by Sri Chaitanya. We are discussing the next mock test for your score exam preparation. This is the grade 11 syllabus that we'll be doing questions on. The previous parts are already there on the channel. You can see them if you haven't seen yet. So we have 10 questions. Let's get started with them. First and foremost, before we get started, many of you who are seeing this video for the first time might think about what SCORE is. So SCORE is the nationwide scholarship exam conducted by Sri Chaitanya. It's conducted for grade 3 all the way till grades 12. This is the grade 11 session that we are doing because we'll do questions on grade 11. But whichever grade you are in, you can give this scholarship exam and you will get up to 100% scholarship in Sri Chaitanya courses. Along with that, you have a bunch of other gifts. You have NASA trips, you have gadgets like tablets, laptops, and most importantly, you'll get to compete with India's brightest students because numerous students give this. All of Sri Chaitanya's toppers have at some point given the SCORE exam as well. Okay, so the exam modes are both online and offline. I'll talk more about the dates eventually. It's 28th September, 12th October, but registration dates I'll mention. And you can register right now for free at srichaitanyascore.com on the website. It's completely free, both online and offline. You can give the exam. Okay, so let's get started with the questions for today. This one says a thief is running away on a straight road on a jeep moving with a speed of 9 meters per second. A policeman chases him on a motorcycle moving at a speed of 10 meters per second. If the instantaneous separation of the jeep from the motorcycle is 100 meters, how long will it take for the policeman to catch the thief? I'll give about 30 seconds for you to solve. Go ahead, solve this question, put the answer in the chat. You have 30 seconds for that. This will require your use of relative velocity. If you do relative velocity, this question becomes a lot easier to work with. Thief going at 9 meters per second, jeep, police going at 10 meters per second, going in the same direction, which means for relative velocity, you would be subtracting the velocities. Then you'll get the relative velocity. The relative distance is 100 meter. You know relative velocity, you know the distance, you can get to the time. Okay, let's start with it. So your relative velocity between the thief and the police would be equal to 10 meters per second minus 9 because they're going in the same direction, so we subtract it. That's 1 meters per second. How much distance do they have to cover? They have to cover a distance of 100 meters. They cover a distance of 100 meters. So in that case, if the relative velocity is 1 meter per second, relative distance is 100 meters, then the time is the relative distance divided by the relative velocity, that is 100 divided by 1. The answer is option D, 100 seconds. Yes, good work, Sujan. No, it won't be infinity, it will be 100 seconds. Okay, we go for the next one. This one says a car is moving with a speed of 50 kilometers per hour. It can be stopped by brakes after at least 6 meters. If the same car is now going at 100 kilometers per hour, what is the stopping distance? So as long as it is the same car, its mass is the same, its brakes are the same. So you know in the first case and the second case, the acceleration is going to stay the same. The acceleration is constant between both cases. Both of them are eventually stopping it, so your final velocity for both of them is 0. Your initial velocities are different and you have been asked about the distance. Think about which equation of motion you can use here to get to that. Which equation of motion you can use here to get to that? Let's see. Should we get started with it? See, the equation that has, we know about final velocity, we know about initial velocities, we know accelerations, we know distance. We are working with them. So the most suitable equation for us is v square is equal to u square minus 2as. I put a minus here because in both cases it is a deceleration. At that point, I know my final velocity in both the cases is 0. If final velocity in both the cases is 0, you have 0 is equal to u square minus 2as. Then I know s is equal to u square divided by 2a, right? It is u square divided by 2a. Now the acceleration is again the same in both of them, which means the distance in which it will stop is proportional to u square. Now what happens? From the first case to the second case, the speed is doubled. Okay? It means I can write it here, s1 over s2 is equal to u1 over u2 whole squared. Right? Now u1 over u2, s1 is what? S1 was 6 meters. u1 was 50 and this was 100. So that's a 2 square. If you cross multiply there, you have S2 is equal to 4 into 6. That's a 24 meters. It is option C, not option A. Many students went for 12. No, it would come out to be 24. Yes, Sujan. Okay. Hi, Kartikeya. Hello. Hi, Anuj. Okay, we go for the next question. This one says a particle is moving in a circle, radius is 4 centimeter, it is moving clockwise at a constant speed of 2 centimeters per second. If x cap and y cap are the unit acceleration vectors along x and y axis respectively, then the acceleration of the particle at an instant halfway between p and q. So exactly over here. What is the acceleration of the particle in terms of its x cap, y cap? Basically it's I cap and j cap. Come on, let's see. It's moving with a constant speed. So the only acceleration would be the centripetal acceleration. Think about which direction does it point. Based on that, you can find the components. Okay, Anuj has gone for option B. Okay, let's see. So the acceleration's magnitude is v square over r, right? The speed is 2 centimeter square, so 2 square divided by the radius is 4 centimeter, right? Yes, so that is equal to just 1. That is just 1. Now, with that 1 centimeter per second square, it's pointing in this direction. You know this is 45 degree. So in this direction, it would have 1 cos of 45. And in this direction, it would have 1 into sine of 45. This is also 1 by root 2. This is also 1 by root 2. So both components are in the negative direction. Both have a value of 1 by root 2. So it is going to be option C, not option B, Anuj. It would be option C. You just don't take this. You have to take the components. If you have to write in the component form, you have to take the components in the I cap and j cap direction or the x cap and y cap directions. Okay, we try for the next one. This says a bus is moving on a straight road towards the north with a uniform speed of 50 kilometers per hour. It turns through 90 degree. If the speed remains unchanged after turning, the increase in the velocity of the bus in the turning process is what? Okay, which direction it has turned is not given. Chalo, we'll try to predict it. We'll try to predict it. It was going to the north. From there it turned. It turned to the west because every other case is given as west. So you can think it turned to the west by 90 degree. What is the change in velocity? Remember, treat velocity like vectors. Think about initial velocity as a vector. You have the north, south, east, west. east-west. This is like the positive y-axis, positive x-axis. Think about it. Initial velocity, final velocity. Okay. We'll start with this. Initially, it is 50 kilometer per hour in the upward direction. Okay, towards the north. So that as a vector would just be 50 j cap. Then it turns to the west. I can see everything is west here. It turns to the west by 90 degrees, like it goes 90 degrees. So the new velocity, this is your v1 vector. Your v2 vector, the speed doesn't change. It just becomes minus 50 I cap. Correct? Which means if I want to find the change in velocity as a vector, that is the v2 minus v1 as a vector, which will give me minus 50 I cap, minus 50 j cap, right? So over here, what do I get? I get eventually this, the magnitude of that would just be 50 root 2, because root over 50 square plus 50 square. And which direction does it turn? How do? I do v2 minus v1, right? v2 minus v1. So if this is plus v1, this is minus v1 vector. So the resultant points here, so that is southwest direction. So 50 root 2, that's 70.7 in the southwest, not northwest. It might appear, oh, it's north, so it's west, northwest. No. Draw the minus v1, you see it will point towards the southwest. Yeah, it is option A. Okay. Next question says, the pulleys and the strings shown are smooth, negligible mass. System stays in equilibrium. Then what is the angle theta? I'm assuming this is 0 degree. I'm assuming that's a misprint. I assume that would be 0 degree. Sorry. Try this. Just think about it. It's an equilibrium, so you don't have to assume any accelerations. Everywhere forces are balanced. Every single place forces are balanced. You want to find what this theta is. It's symmetric on both sides. This side is also theta. This side is also theta. We'll start. See, over here, if you look at this mass, there is the mg and there is the tension. You know, because there is no acceleration, this tension should be equal to mg. Same way you would have the mg, you would have the tension, that tension would also be equal to mg. Both of those tensions are pulling in this direction here. Now, this is pulled down with its weight of root 2 into mg. And it is held up not just by those tensions, but the cos theta components of those tensions. Because in this direction, you will have t cos theta. One t cos theta from this side, one t cos theta from this side. Total would be 2t cos theta. That is balancing out the root 2 mg. Right? Now t in itself is equal to mg. So 2 mg cos theta is equal to root 2 mg. Take the mg's out. This goes with the root 2, so I get cos theta is 1 over root 2. So my theta value I know has to be 45 degree. Yes, correct Madhavi, it is option C, 45 degree. Good. Next question. This says a monkey is descending from the branch of a tree with a constant acceleration. Braking strength is 75% of the weight of the monkey. Then the minimum acceleration with which the monkey can slide down without breaking the branches. Lots of spelling mistake throughout, but you get the idea about what it is. Okay. Braking strength means the maximum value of tension that can be there in the string. That is 75% of the weight of the monkey. So treat the monkey like this, like a regular wire, and it's hanging. And it's coming down with an acceleration, because that's what's asked, the minimum acceleration with which he can slide. Remember, when the minimum acceleration is happening, the tension is at its maximum value. That is 75% of mg means 3/4 of mg. This will be pulled down with mg. Just write the equation and you'll get the A. Come on. Okay, Madhavi has gone for option C again. See, downwards you have mg, minus upwards you have 3 mg by 4. If this is m, then that is mass times the acceleration. Take the m's out throughout. So A is equal to g minus 3g by 4, which will give you g by 4. Yes, correct, Madhavi. It is option C. Good. We go to the next one. It says a rubber band is stretched by a distance x. Then it exerts a restoring force, where the restoring force is given like this. It's not just a spring which is F is kx. It's given F is equal to ax plus bx square. It is said, here we are constants, work done in stretching an unstretched band by a distance L is how much? You just have to go through the work done over here. F dot dx. Limits go from 0 to L. Work done is F dot dx. Your limits go from 0 to L. Let's see. Come on. We'll start solving. See, you want the work done. That's just integration f dot dx, right? What are the limits? Your elongation, originally it was unstretched. From there you stretch up till a distance L. Up till the elongation is L, okay? Stretching it by L. So we just plug it in. Ax plus bx square dx going from 0 to L. What will we get? Ax square by 2 plus bx cube divided by 3. Just doing a basic integration. Limits go from 0 to L. So if I just plug it in, I will get Al square by 2 plus bl cube by 3. It is option C. Correct, Madhavi? Okay. Next one. In the figure shown, a particle of mass m is released from a position A on a smooth track. When the particle reaches point B, normal reaction force on it by the track is how much? So this will require both your concept of work per energy as well as centripetal force, centripetal centrifugal. HCV, all PYQs, all modules. I will say more than HCV, do all PYQs, do all modules. If you have finished the modules finishing doesn't just means that I've gone through, seen the examples. Modules finishing means any question if I'm giving you from the modules, you should be able to do it. If not, revise the modules once more. Once that is done, pick up a book like Physics Galaxy or a book like Shashi Bhushan Tiwari. That will suffice. HCV you can do, but I don't think just with HCV, again you'll have to do HCV full every single question by your own self. Rather, if you have lesser time, a book like Physics Galaxy will help you, especially the Physics Galaxy 700 illustrations. But if you have HCV and modules, but when you do PYQs and modules, if you are also doing the advanced PYQs and modules, then yes, it could suffice if you are able to do them by yourself. Otherwise, you'll need a bit more practice. For that, you can pick up any external book if needed. Think about it. You release it from a height 3h, right? If you release it from a height 3h, when it is at the stop point, it is basically at a height of 2h. So from this point to this point, it has only come down by a distance h. So what speed will it have? Half mv square would be equal to just mg into h, because the change in height is just h. Take it out, you will get v is equal to root 2 gh. That is the speed over here. Now if it is moving with that speed and it's moving in a circle whose radius itself is h, so you know on that mass, in the downward direction you have mg acting, right? And you also have the normal reaction acting from the wall. They both together are what give the required centripetal force for it to turn. Okay? So you have n plus mg is equal to mv square divided by r. So n is equal to mv square divided by, what is the radius? Radius itself is h plus minus mg. What will mv square be? You can see mv square would be 2 mgh. Just from here, if I cross multiply the two, I'll have 2 mgh divided by h minus mg. The h cancels out, you'll have 2 mg minus mg, so your n will just be equal to mg. Rahul Sardana, you can, but I will rather say first prioritize your PYQs and modules, then pick up any external book. Don't first pick up a book. Always first PYQs and modules. This one says the ring of mass capital M, radius capital R is rotating with its axis, about its axis with an angular velocity omega. Now two identical bodies, both of them having mass small m, are gently attached at the two ends of the diameter of the ring. Then because of this, what is the kinetic energy loss? Okay. Think about it. You first need to find what the new angular velocity is. Then you can go between the initial energy and final energy. I'll give a little time. Let's check. Originally, what is the original moment of inertia? It was just mr square, because just a ring of mass m, radius r. In the second case, what do? On the ring, I attach two extra masses of small m, both at the same distance r. So the original moment of inertia is there for the full ring. But with that, I also have 2 mr square because of this one, mr square because of this. So I get the two moment of inertias. That way, I know by conservation of angular momentum, I1 into the original angular velocity omega is I2 into the new angular velocity, I'll call it omega naught. So omega naught is equal to I1 by I2 into omega. So I1 by I2 is mr square divided by I2 is r square. If I take common, I'll have a capital M plus 2m and an omega square. Take the r square out, I got the new omega naught. Now remember, I just have to use the energy in the before and the final case to get what is the loss in energy. So what is the initial energy? It was just half I1, it was rotating with an omega square, right? And in the final case, it would be half new moment of inertia into the new angular velocity square, omega naught square. This is what? Half mr square omega square. This is what? Half New one is r square, capital M plus 2m r square into omega naught square. Omega naught square is what? Over there we have, sorry, it's just omega, not omega square. My bad. M divided by m square by m plus 2m whole square into omega square. Right? We can take one of this out. Now I need to go for the change in kinetic energy. That is the initial minus the final. I can take half mr square omega square common. You see both of them have that. Half mr square omega square I can take common. This will just keep a 1. This will give me an m divided by capital M plus 2 small m, which will make it half mr square omega square into capital M plus 2m minus capital M divided by capital M plus 2 small m. Take them out. So, do we have it in this form? We can take the 2 also here out. So, I will have capital M small m r square omega square divided by capital M plus 2 small m. It is option C. Yes, Narasimha Rao, you are right. Conservation of angular momentum only we used. Then we had to again go to the energy as well, because we are trying to find that change in energy. Try the next question. This says a ball rolls without slipping. Radius of gyration of the ball about an axis passing through its center of mass is k. If the radius of the ball is r, then the fraction of the total energy associated with the rotational energy will be how much? Rotational kinetic energy, I means moment of inertia about axis or moment of inertia passing through center of mass. About the axis. About whichever point you are finding the omega, about whichever point it's rotating, because about that only you are finding the omega. So if that is about the center of mass, yes, that one. If suppose there's a rod like this, rod is fixed here and it's turning about that, then you will take moment of inertia about that edge. About whichever axis you get the omega. Okay. This one, think about it. The translational kinetic energy is equal to 1/2 mv square and the rotational kinetic energy is 1/2 mv square into k square by r square, where k is that radius of gyration, right? So that way, if you want the fraction of the total energy with the rotational energy, that is just kr divided by the total, which is kt plus kr. That is 1/2 mv square k square by r square divided by 1/2 mv square plus 1/2 mv square k square by r square. Take the 1/2 mv squares out. What am I left with? I am left with k square by r square on top divided by 1 plus k square by r square, which will give me, if you calculate, k square divided by r square plus k square. It is option B. Okay? Clear with this? We'll move to the next one. Oh, I think this was the last question. So next week we'll have another session on Friday where we'll discuss even more questions. For now, those who are attending for the first time, this is your score syllabus. You'll have 20 questions in physics, 20 maths, 20 chemistry, 120 minutes exam, so 2-hour exam. This is your physics, chemistry and maths syllabus. I'll step aside for a moment so that you can go through it. So for physics, you only have the system of particles and rotation. In chemistry, you have basic concepts, atomic structure, classification of elements, bonding, and thermodynamics. And for maths, you have sets, relation functions, trigonometric functions, sequence series, straight lines, and limits and derivatives. Okay? So go ahead, you can register. The registrations for test date 1 is 28th, last date is 26th. The exam is on 28th, and so 26th is pretty next week itself. And last date for test 2 is 10th October. The exam would be on 12th. Now remember, this depends on which center. It's not like you can choose. Obviously you can choose, but maybe the center will be further away from you. So preferably register before 26. That way you'll have access to all the centers where the exams are getting conducted. So we'll keep this session till here, students. If you like this video, make sure to hit that like button. Stay subscribed, because more information, more practice sessions would be coming on for you. So we'll keep this session till here. Thank you all so much for tuning in for this session. I'll catch you all again in the next one.